Hello and welcome to our Engineering Science Fair project, where we created a 3D printed autonomous rover by Ashia, Omair, Zosia, Ridley, and Burke.
So the team's project includes designing and experimenting with rocker bogie mechanism, wheel designs, and wheel modules in order to create a wheel suitable for rocky extraterrestrial terrain. The engineering goal was that the rover will autonomously be able to travel across rough terrain with high friction and withstand a tilt of 45 degrees with 3D printed carbon fiber wheels. Even though prior research on wheel designs for rovers have been conducted by NASA, developing these rocker bogie mechanisms with cheaper materials could contribute to providing aid in low-resource areas. The team experimented with 4 different wheel shapes, 3 of which were designed by the team. So our rover was assembled with a 3D printer and was powered by a Raspberry Pi 4. After printing each wheel, we tested its traction and stability through trials along different terrain and its stability through trials on an inclined plane. Regarding our rover's traction, we tested its speed on sand and on gravel and compared the two results. Stability was measured through placing the rover on an inclined plane, each trial adjusting the incline and seeing if there were any slippage or falls. We did this on an incline of 15, 30, and 45 degrees.
From our data, we saw that the traction in the chevron pattern wheel was the highest, as the wheel produced an average speed of 6.67 centimeters per second, the slowest of all the prototypes. The sturdiness of the chevron wheel was also successful, as the rover was stable on inclinations of 15 degrees, 30 degrees, and 45 degrees. However, the curved wheel prototype, not designed by the team, was also stable in all 3 inclinations, and had a very close average speed to the chevron wheel at 7 centimeters per second. Here we have 2 pictures of the rover during our experiment. On the left we have the rover on the gravel terrain, and on the right we have the rover on the sand. And in both of these pictures, the rover has on the chevron wheel.
The results from the data indicated that the chevron wheel pattern designed by the team was the most efficient for traveling across rocky terrain and being able to withstand an inclination of 45 degrees. However, the curved wheel prototype not designed by the team was also stable in all 3 inclinations, but did have an average speed of 7 centimeters per second, as opposed to the chevron wheel's average speed of 6.67 centimeters per second. The wheel with the slowest average speed was deemed the most efficient, as the slower speed equals higher traction. One particular detail that would definitely be implemented if this project were to be done again would be to increase the depth of each groove to give our rover more of a grip on the surface it runs on. Another would be to test the rover on mud as well as other surfaces. Our chevron wheel pattern accomplished our goal in that it had enough traction for all 3 surfaces as well as the stability to stand on all 3 inclines. This project greatly heightened our mechanical assembly skills and knowledge of basic engineering, as we were able to practice through trial and error in the printing process as well as the assembly. Not only was this project a great learning experience, but it can be used elsewhere as well. In an educational setting, 3D printers can be promoted and used by implementing this project into classrooms, and these cost-effective materials can allow areas with limited resources a chance to experiment as we did and build smaller mechanisms. Here are our references. Thank you.